Today we're going to be learning about similarity in different shapes, and we'll be taking notes on pages 41 through 42, doing a practice exercise on page 45, and going through some word problems on page 48. So thanks for turning to page 48. Let's go ahead and go through these word problems and see if we can create some proportions to find some missing information. On this page, all four of these problems require us to visualize something. So I am going to go ahead and show you my amazing artistic skills and show you what I would have drawn for these situations. So question 1 reads like this. A flagpole casts a shadow, so here's my flagpole, of 27 feet. So this is the shadow of 27 feet. And it says that a person standing nearby, there's the person, casts a shadow that's 8 feet long. So let's label this 8 feet long. Then it says, if the person is 6 feet tall, how tall is the flagpole? So this person is actually 6 feet tall, and they want to know how tall is the flagpole. Well, I can see already some corresponding lengths here. The length of the flagpole corresponds to the height of the person, and the length of the shadows also correspond to one another. So I could say that x corresponds to 6 feet, so those are the heights of the flagpole and the person, to the shadows that they created. So the flagpole created a shadow of 27 feet, and the person created a shadow that was 8 feet long. Now we know how to solve a proportion like this. You should have multiplied, and you would have gotten 8 times x equals, I'll be your calculator, 27 times 6 was 162 feet. And if you divide by 8 on both sides, you would get that x equals 20.25 feet. So this flagpole is 20 feet plus a little bit more. So what I hope you're starting to notice is that, solving these types of proportions is really not too challenging. What makes a word problem challenging is, are you able to take these words and turn them into some sort of diagram where you can clearly see the corresponding lengths? If you can't draw the diagram, you can't create the proportion. And if you can't create the proportion, you can't find the missing value. So that's what I want you to be really focusing on. Okay, so for question 2, let's go ahead and read question 2. Let's say goodbye to our flagpole. Here's question 2. Christopher wants to reduce a triangular pattern with the sides 16, 16, and 20 centimeters. If the longest side of the new pattern is 15 centimeters, how long would the other two sides be? Okay, when I see the word reduce, I know they're saying that they're going to create a dilation. And a dilation creates similar shapes. That means that the corresponding sides of these triangles are proportional. So there's my cue to use proportions. Okay, so our original triangle is in the patterns of the sides 16, 16, and 20 centimeters. So let's label that. I'll say this side is 16 centimeters, this side is 16 centimeters, and this side is 20 centimeters. And my new triangle is going to be reduced, so I made it a little bit smaller. And the longest side is going to be 15 centimeters. Now I know these two sides are equal, and in my new triangle, these two sides will be equal. But they're wondering, how long would the other two sides be? Well, let's create a proportion. I know that my side that is 16 centimeters long corresponds to this side, and their relationship is the same ratio as this length to this one. That means that 16 over my mysterious length is equal to 20 over 15. If I multiply, I can get 20x, so I'm multiplying x times 20, is equal to 16 times 15, which is 240. And if I divide by 20 on both sides, I'll get x equals 12 centimeters. So that means that these two side lengths, how long would the two sides be? These two side lengths would be 12 centimeters long. Okay, let's try this again. Here we are at example 3. A 9-foot ladder leans against a building 7 feet above the ground. All right, this one's tricky to visualize. A 9-foot ladder is leaning against a building. So this little ladder right here is leaning there, and it happens to be 9 feet long. Now they also said that it is 7 feet above the ground. What they're saying is that this point right here is 7 feet from the ground. So let's label that. This part right here is 7 feet from the ground. Okay. Now it also says that there's another ladder that's 15 feet long. Okay, so it's 15 feet long. So this would be that longer ladder. So this ladder right here is 15 feet. And they're asking, at what height would a 15-foot ladder touch the building if both ladders form the same angle with the ground? Now, I just want to point out that they're talking about this angle right down here with the ground. But if they were to form the same angle to the ground, they should be parallel. That's why I drew them like this. Now we want to write our proportionality statements, but in order to do that, I really want to take a closer look at these shapes that are here. And I see a small triangle, and then I see a large triangle, and you may also see it, but let's go ahead and separate them so we can take a better look at them. So this side is 15 feet, and they're asking me how high up would that ladder hit the building. And then this smaller ladder is 9 feet long, and it's 7 feet off the ground. Now when I separate the triangles, and this is something that you can easily do when you're doing a word problem also, if you find that your shapes are overlapping or on top of each other, I encourage you to separate them so that you can clearly see the corresponding sides. In this case, I can see that the 7 feet height has a relationship with the X height, and the 9-foot ladder has a relationship with the 15-foot ladder. Now I can easily create my proportionality statement. So 7 feet has a relationship with the height of the second ladder, and the 9-foot ladder has a relationship with the 15-foot ladder. Now this is easy to solve. 9 times x is 9x, and 7 times 15 is 105. Now if I divide by 9 on both sides, you're not going to like this, you get 11.6 repeating feet. So it's a little more than 11.5 feet. Now our last example is a lot like example 2. Here's what it says. Sam wants to enlarge a triangle with the sides 3, 6, and 6 inches. If the shortest side of the new triangle is 13 inches, how long will the other two sides be? Okay, I heard the word enlarge, so this is a dilation, so that means that these two triangles are proportional. Now, I heard that the smallest side was 3 inches, and the other sides were 6 inches. So this is an isosceles triangle. Now they're saying the smallest side of the new triangle is going to be 13 inches, but they're curious about what the other sides will be, and we don't know what they'll be, so we're going to have to do some math there. So let's find some corresponding sides. My smallest side, 3, has a relationship with 13. So 3 has a relationship with 13. And my second set of corresponding sides, and you can choose whichever one you want, is 6 to x. When I do my math here, I'll get 3x equals whatever 6 times 13 is. Well, 6 times 13 is 78. And if you divide by 3 on both sides, you'll get that x is 26, or 26 inches in this case.